Hi, in this lesson, we talk about automatic type conversion functions, which are used to convert one type of data to another, and miscellaneous functions. Let's get started. Oracle supports automatic type conversion, which means if the given value is not of the required type but can be converted to required type, Oracle automatically converts it. For example, any number or date can be converted to character. So if the context needs character, but what you are giving is a number or a date, Oracle will automatically convert that to character. Similarly, if a character is given where a date is expected, it will try to convert character to date provided the value is given in the required format. But date can never be converted to a number can never be converted to date. So these are some guidelines related to automatic type conversion. Let us see how that works. So here, if I say I want to multiply 10 with 20, now this is where I'm trying to multiply 20, a number, with a string, but Oracle knows what it needs is a number, so it will try to convert this to a number. Let's go, and you can see the conversion is done automatically. And similarly, if you try to use something like length of 1, 2, 3, 4, what we are giving is actually a number, but what is expected is a character. Because length is a string function, it expects a character. But still, it works because Oracle can convert this number to a string. And similarly, you can convert a string to date. For example, sysdate minus, and we are giving something like a date. So here, if I say months between, this is where I need something like two dates, and I'm giving one date, then comma another date. I can give something like 1st January 2018, for example. It'll give me how many months are in between these two, because it knows that it can convert whatever is given there, though it is of type character, it's converted to date. These are some of the examples where Oracle automatically converts. But there are cases where it cannot do that. For example, if I try to subtract system date from days, I mean, if I try to subtract a date from another date, but the date is not given in date data type, it's given as a string. So according to us, if you give a string, but if it is in the date format, Oracle can convert. So let's try and see whether it can do it. When you go ahead, it is not doing that. It is not able to convert the given value to required type because it's a little confused. As you can see, it is saying it's an invalid number. It's treating it as a number. The reason is simple. We have a possibility, like we have a case where you can have a date subtracted from date. Also, you can have a number subtracted from the date. This is about number of days to be subtracted from date. So in between these two, when you give a string, Oracle is trying to treat it like this. So it assumes what you are giving is a number because it's not a date, it's a string. It'll try to first convert that to number, and that is not working. And that's exactly what the problem here is. So how do we fix it? Well, the solution to this is our conversion functions. By using conversion functions, we can explicitly convert the given value to the required type. So toDate is what we need to use in this context. So if I can use toDate and then give the value Then Oracle understands this is to be converted to a date, then it will proceed with the operation. So there are a few cases where you have to explicitly convert a given value to a required type. In such a case, you have to use the function toDate, toCharacter, and toNumber. Those three are called as conversion functions. And if you look at the formats, especially for toCharacter and toDate, you can give these characters to specify how the value should be treated. So going back, what if I'm giving something like 2018 1 and 1? This is not something that is understood by Oracle. So there it is throwing error, saying this is not something it understood. That's fine. Now we can tell Oracle that this is to be treated as year, and then we talk about month, and then the date. So now it understands how to interpret those numbers, and again we get the result that we want. So toCharacter and toDate both can make use of some characters, the formats, and here are those characters. They are used even in toCharacter. So let's go to toCharacter and see how that can be used. So normally when you say sysdate, you get only the date part. But I want to take not just the date but also the time part. So I can use hh24 colon mi, and that will take the time portion from that. So there you see it's now 31st August 2019 and 11:50. I'm talking about hh24 means 24 hours format. And if I give HH and then give something like PM, it's going to give me something like this. It's 11:50 AM. Though you give PM, it is going to give you either AM or PM depending on the time of your system. So this is how I can extract the time portion from the sysdate. You can do that for any date. And of course, you can also display the date itself if you want, like this, and then you can get the time part of it. So in this case, I don't need to display that separately. In one stroke, I get both date as well as the time. So toCharacter is to convert a date to a string, but it can extract whatever you want. Of course, if you want, you can just take only a single part of it. Sometimes we are interested in getting only the year, nothing else. So this is what we can do. If you go run this, you will get only the year and nothing else. So how can we use it? Well, I want to find out employees who joined in the year 2005. So I can say select first name, comma, hire date, comma, salary, some details from employees, where I'm saying, if I say something like hire date, this gives me the complete date. But I'm only interested in one part of it. So one way to do that is to convert this toCharacter and extract only year and then compare that with whatever you want. So this is where we are looking for employees who joined in 2005. You can see these are the employees who joined in 2005. So that's the application of conversion function, toCharacter, toDate. In certain cases, even toNumber will be of use. And then if you talk about the miscellaneous functions, miscellaneous functions are the ones which are not specific to any data type. They can be used with different data types. And we have some examples here. The first miscellaneous function is a decode, which can be used to compare the given expression with the given values. If department ID is 10, then we will be taking the value 0.50. If department ID is 20, then we take 0.75. And if it is neither of them, then it will go for 0.25. This is a kind of if-else structure. So decode is pretty powerful. With the help of this, we can compare one value with multiple values. Wherever it is matching the value, we take the corresponding value. So this is to calculate the bonus of the employee, which happens to be 50% if employee belongs to department 10 and 75% if employee belongs to department 20. Otherwise, the rest of them would get 25%. That's the way it goes. Now, that's the first example. Here, I want to find out what is the greatest of the given two values. So this is where I want to know which is greater. Is salary by 2 is greater or 1000? Because I want to take the greatest of these two values and then use that. Maybe we are announcing some bonus and we want to make sure that everybody gets at least 1000. So half of the salary or 1000, whichever is higher. So that's greatest. The opposite to that is least, whichever is least. So we want to make sure nobody gets more than 1000. So this is the value. If it is less than 1000, employee would get this. Otherwise, he would get 1000. This is what we typically see in many online shopping scenarios. They say you get a discount of 50% subject to a maximum of 1000. That means if your 50% is less than 1000, fine. Otherwise, you get only 1000. And then we have a couple of functions related to null, and they are extremely important. Let us see what is the purpose. Let's try to find out the net salary of the employee. So how do we calculate? Net salary is salary plus the commission. So salary into commission percentage. Commission percentage is the percentage of commission employees entitled to get. It is calculated as a percentage on the salary. So salary plus commission is going to be the net salary. That's fine. Let's go and try. This is what we are getting. What is that? Null. For many employees, the total salary is null, but for some, it is giving valid value. What's happening? Well, this is another very important part of any database, especially Oracle. So what we do is salary, let us say, is 5000. And then we want to say salary into, and for this person, let us say the commission percentage is null. When commission percentage is null, then the expression is going to return again null. Any expression involving null returns null. That's a point worth noting down. Any expression involving a null value again returns null. So we get null from this, and that plus 5000 is again null. That's exactly what you are seeing for all these employees, because their commission percentage is null. So we are going to get only null as the final result. So how do we solve this problem? We solve this problem by treating this null as 0. If I can treat null as 0, then this is going to be 0 into salary, 0, and 0 plus salary is going to be the actual salary, and that's the way we solve the problem. But how do we do it? Well, here it is. You go to a function called NVL. NVL function says, give me the expression, and if this is null, I will return this. And if it is not null, this is returned as it is. So the correct way to calculate net salary of the employee is salary plus salary into not directly commission percentage, but NVL of commission percentage comma 0. This is what we need to use. So this is a very, very important function because it can help you to treat null as something else, because null values are not going to go well in expressions. So here is an example, and now we will fix this. So how do we fix it? NVL of commission percentage comma 0. So if commission percentage is null, we treat it as 0. Otherwise, we take it as it is. Go ahead. Now everything is fine. Now all employees get proper net salary. So that's how we need to use those functions. And there are a few more versions of NVL, like NVL2, null if, and coalesce is a function which returns the first not null value. So it is going to examine the given values, whichever is not null, it takes that and then it stops. So this is an example for coalesce. And I'm trying to find out from locations table, postal code, state, province, city, and in that order. So if postal code is null, we ignore. If state, province is also null, we ignore. Then if city is not null, we take it. But in a particular row, we do have a postal code, straight away it would pick that. So that's the way it is going to work. It's called coalesce. Very interesting function. And then we also have not a function actually, it's called case expression. And this case expression can be used just like a decode, but it's more flexible, more readable. So I say compare job ID with IT programmer. If job ID is IT programmer, then I want this to be returned. And if it is not IT programmer, then check whether it is sales rep. If that is the case, we want this to be returned. In all the remaining cases, I want to return this. So this is called the case expression, and we want to take the value and we want to display that as new salary of the employee. So this is a case expression. There are some other flavors of it that we will see later, but for now, this is the way it goes. So the whole expression will end up as one new column here. So you get first name, job ID, salary, and also the new salary of employee. So that's about case expression. And that's all in this lesson. So we understood automatic type conversion that is available in Oracle. We understood how to use two character and two date functions, two of the commonly used functions for type conversion. We understood miscellaneous functions like a decode, greatest, least, but the most important of all is NVL, which is very widely used. And also we looked at case expression, but there are other flavors like case statement, which we will see later. Okay, so get used to them and we'll resume in the next lesson.